Good afternoon. Mark Thompson here for Real Time with IPC. I'm here this afternoon with Graham Naisbitt from Gen3 Systems from the UK. They provide feedback on solderability, especially about counterfeit components that we're seeing more and more these days. Traditionally, this was a situation where an engineer would do sort of a dip and look, if you will. They actually have a machine, the MUST, that is a quantitative measurement for force testing, which ultimately means that there is traceability for this particular product. Graham, tell us a little bit about this product.
Well, the MUST originally was developed out of a European joint venture trying to create a good measurement, scientific measurement ability to detect the effects of oxides on the surface finishes of component terminations, leads and board pads. The technique involves a very sophisticated force measurement device, an LVDT that measures in millinewtons the amount of forces that are occurring. As components are tested, they are presented to either a bath or a globule, and as the component termination comes into contact with either the solder in the bath or on the globule itself, the amount of forces occurring as they wet can be measured very, very precisely, and this gives a very distinct wetting curve that of course equally gives you full traceability in the longer term. Good engineers traditionally would do this using the dip and look approach, but of course if you dip and look, good engineers can probably do that, but where's the traceability?
Exactly. Well, very good. I understand that as far as creating a profile, if you will, for the component on those good components, then this also translates to checking to make sure that you don't have any counterfeit components in your system as well, because obviously they're going to show up as a different profile. How does that work?
Well, that was the particular interest for us, and it's something that's occurred fairly recently when we discovered some of our customers are actually utilizing the MUST as a method of first pass detection. When you have a good component, you can run the test and it will give you a force curve, a signature, and if you then have a component that does not exhibit the same wetting forces through the speed at which this occurs, it will generate a different signature that would indicate a problem may be present, so the part can then be taken off to one side for further examination using other techniques such as XRF as an example.
Understand.
But it's growing in popularity, and of course the phenomenon of counterfeiting has risen exponentially over the recent period, and of course those in high reliability, safety critical avionics applications, this is of really great significance.
Absolutely. Well, you pretty much answered my last question, which was, this is very pervasive, and how is this going to affect the industry, which you pretty much just addressed. How has the show been for you folks?
The show has been absolutely marvelous. I'm bound to say, having been attending these meetings for 20 years or more, this is much more like the old days. We have had a tremendous success through the whole event. It'll be a shame to go home.
Absolutely. Well, thanks so much. I've been with Graham Naisbitt from Gen3 Systems from the UK. I'm Mark Thompson for Real Time with IPC. Thanks so much.
Thank you.